So in this lesson, we are going to study what? Numeric type conversion or typecasting. So what do you mean by numeric type conversion or typecasting? We know that there are 6 numeric types are there, which are namely byte, short, int, long, float, then double. You see, if I create a variable, let's say I say byte b equal to 10. So what happens in the memory when we do this one? Let me open this sketchbook. For B, some memory is allocated. So B is basically 8-bit. So you can say 8 bits of data gets allocated. Okay. So and the 10 is stored here. So basically, in the bits, so few things will be set to 1. This is the binary numbers. So on the high level, just understand like this. Memory is allocated to byte and the value 10 is stored in that location. Now, if we say short yes equal to 10, same value, what happens in the memory now? Memory gets allocated for the variable yes, and it is pointing to a location where that memory is allocated. You see now, the total amount of memory is allocated is double of byte. It's basically double of byte. And here also value 10 is stored. You see, understand this one. If I say instead of equal to 10, if I say B, what's supposed to happen? What are the values stored here? Should be assigned to this memory location. Now the way this 10 has been represented, is different here, and the way it's supposed to be represented in this location is different again. So what happens? Casting happens. Even though short is an higher data type than B, still the casting will happen. That is from lower data type to higher data type. So that means if I am doing a casting, from lower data type to higher data type, so any variable of type byte or of type short can be assigned to int, long, float, double on the right part. So there is no explicit casting is necessary here. Why? The reason is simple. Implicit casting will happen. So in the casting there are basically two types. One is implicit casting. Second one is explicit casting. Now, implicit casting is something done by Java virtual machine itself. We no need to bother about it. So from lower data type to higher data type, we no need to do any implicit casting at all. Not necessary. But know this one, casting do happens. So what is casting? Converting the value from one data type to another is called as casting. In that there are two types. First one is implicit. Implicit casting is done by Java virtual machine and it happens internally. That's why it's called as implicit casting. Why? No explicit statement is written here. Suppose we have a variable, let's assume I have, let's say, double variable equal to 123.123. Now I want to cast it to integer. Then int, let's say I equal to, I cannot say like this. If I do this, I'll get a compile time error. See, here I'm not getting a compile time error from lower to higher type. But here I'm going to get a compile time error. Let me prove it to you. Java C test.java Oh, sorry. Let's put them in an multi-line comments. Star slash. Okay. So we're getting a compile time error. Incompatible types. Possible lossy conversion from double to int. So the reason is because JVM is capable of doing implicit casting from lower data type to higher data type, whereas from higher data type to lower data type, JVM cannot do the implicit casting. So we have to tell exclusively to Java virtual machine that, dude, do the casting. How do you do that? What are the destination type is there here? That should be specified within the parenthesis. There's nothing to print as an output. Suppose if I print, so what do you think is the output? I think you have guessed it already. That is 1 to 3. So what we lost here? We lost 0.123. So we can say explicit casting. Explicit casting is the casting where we are telling Java virtual machine that, dude, I am okay to lose the value. I am ready to take the loss, if at all, if there is a loss. But you do the casting. So when we do the casting like this, there could be loss. There may not be any loss at all. And in the implicit casting, there is no question of loss at all, because lower data type, that is byte, will have a range minus 128 to 127. So if you go to short, int, long, float or double, they are perfectly capable of occupying that. So obviously there is no loss at all. Whereas from explicit casting, there could be loss. See, let's take an example, one pictorial example. I have a beaker and I have a smaller beaker. From smaller beaker, I'll put the water to bigger beaker. Assume there is some water here. There is no loss. Whereas, take the situation other way around. From bigger beaker, I will pour the water to smaller beaker. If the amount of water exists in the bigger beaker, if it is less, there is no loss. But if it is more, there could be loss. There is loss. And this is explicit casting. This is explicit casting. So there are chances when the values are more, when the value quantity is high, that my lower data type cannot have it. In that case, there could be a loss. So explicit casting is the way to tell Java virtual machine, you do the casting. If at all, if there is a loss, I will take the loss. Now also know this one, explicit casting can be done from lower to higher type also, like this. You see this? So from explicit casting can be done from lower data type to higher data type also, but it is not necessary because JVM itself will take care of it. So this type of casting is called as widening, whereas this type of casting is called as narrowing. Let me give some examples for this. So what do you think will be the output? It will be 1.0.